Hello, my name is Sarah Sebo, and in this video I'm going to present an overview of our paper titled Robots in Groups and Teams, a literature review. Robots are increasingly interacting with people in a variety of work and public settings, delivering food, helping customers find products in retail stores, assisting in manufacturing tasks, delivering supplies in hospitals, and scanning for spills and empty shelves in supermarkets. From these examples, we see that robots are often interacting with multiple people at the same time, which makes sense because people rarely live or work alone. The CSCW research community has cultivated a rich body of work examining the impact of computers and computer-mediated interactions on human groups and teams. Existing frameworks in CSCW have predominantly theorized these technologies as tools or infrastructure to support teamwork. However, these theories do not well extend to robots with high levels of perceived agency that can take on roles within groups as teammates or constituent members. Within the human-robot interaction community, research has been transitioning away from dyadic interactions with one human and one robot to interactions with groups. As researchers begin exploring robot interactions with multiple people, it has become clear that several aspects of the interaction change when a robot engages with multiple people as opposed to a single person. Notably, groups of people are more likely to engage with robots. For example, Booth et al. Showed that college students were more willing to let a robot enter their dormitory building when they were in a group as opposed to if they were alone. Groups of people are also more likely to exhibit more aggressive behavior towards robots, as shown in Brzik et al.'s observations of children bullying a robot in a shopping mall. Groups of people also have within-group human-to-human interactions, which Light et al. Believes may be one contributing factor to why individual children show increased recall of educational content compared to groups of children. And finally, Light et al. Also demonstrated that individual children and children in groups express their internal states differently, indicating that models of human behavior must take into consideration whether a person is alone or interacting with other people. The additional complexity and emergent behaviors present in groups of people constitutes a fundamental change in complexity that is neither captured by current theory in human-robot interaction, nor do existing technical approaches for human-robot interaction readily scale to groups. For these reasons, we reviewed studies focusing on robot interactions with groups of people to provide both an objective insight into where the field stands to date and further push researchers towards areas of potential need and interest. Our review included peer-reviewed research studies that satisfied the following criteria. 1. The study must include at least one physically embodied robot. 2. At least two locally present people must interact with the robot simultaneously. 3. The robots must be autonomous or perceived to be autonomous interactants. 4. The study must explore group-level phenomena and provide a direct contribution to our understanding of how robots interact with and influence groups of people. Using our inclusion criteria, we conducted an exhaustive search of papers within top-tier HRI outlets, papers of the attendees of the Robots and Groups CSCW 2017 workshop, papers that appear using Google Scholar search terms, and papers identified through other means. After a refinement process, our corpus consists of 101 distinct research studies. Next, we highlight several key findings from our review. First, we found that both verbal and nonverbal robot behavior powerfully shape group interactions. For example, Correa et al. Demonstrated that robots that verbally express group-based emotions as opposed to individual-based emotions lead to increased levels of group identification and trust. With respect to nonverbal behavior, Scansa et al. Showed that a robot's use of gaze cues can significantly influence its ability to regulate turn-taking in group interactions. We also found that robots take on different roles depending on the group context. By graphically representing the studies in our corpus on the dimensions of setting, number of studies, and robot role, we observe that certain types of settings seem to suit particular robot roles better than others. For example, in settings where the desired behavior of the robot is repetitive and consistent, like for robots that explain museum exhibits, robots are often put in the role of a leader. When looking at the types of groups that robots interact with, we found that there has been substantial growth in the research attention paid to robots interacting with task groups, as shown in Figure 6b. As robot capabilities continue to improve and an increasing number of robots are developed to join teams of people, it is likely that work focused on robot teammates in task groups will continue to grow. Finally, we also found a focus in recent work on how robots can influence human-to-human interaction in groups. For example, some of our work has demonstrated that a robot's verbal expressions of vulnerability can have ripple effects in a group by increasing how likely human members of the group are to be vulnerable with one another. Our paper also contributes to theory describing a robot's role and impact within a group or team by adopting the input-process-output framework previously proposed by McGrath and Hackman and Morris. We conceptualize a robot's behavior and role within a group as an additional input factor to a group's interaction process, which in turn influences the group's outcomes. Thank you for watching this video, and we encourage you to read the paper to learn more about this exciting research area of robots interacting with groups and teams of people.